Hey there, everyone. My name is Ryan Schul. Welcome to my analytics channel. So in the topic today, I want to discuss the differences between combinations and permutations, okay? So let's just jump into it. This video should be pretty short. It's pretty easy to make a distinction between these two concepts. Basically, with combinations, the order does not matter, okay? So you can have um, things arranged any way you want. Order doesn't matter. With permutations, the order does matter. So permutations are always greater than combinations for the same n and same r. We'll see an example of that in just a minute. Basically, what we call a combination lock is almost certainly a permutation lock because the order matters. Okay, but why is this? Why is it? Is this a mistake in terminology or just the overall use of the phrase? Not really. In the 19th century, when safe and lock making came into being, advertisers came up with the idea of combination safe locks. These are locks that are opened by combining a sequence of dial positions instead of using a key. And safe manufacturers were not really mathematicians, right? So now we have two different terms that mean two very different things. A combination lock could be called a permutation lock because the order actually does matter, and with permutations, the order matters. But originally, it was kind of a misnaming of the device. It was called a combination lock. But really, with combinations, the order does not matter. Okay, so let me show you a couple of quick examples, and I think this is going to make a lot of sense. So basically, I created a small function over here called show, and I am going through different iterations of letters here and looking at the different either combinations. I can have AB, AC, or BC. With permutations, remember the order matters, right? So you can have different numbers of permutations. So like I said before, permutations are always greater than combinations. Permutations, the order does not matter. Combinations, the order matters. So it can only be used once. So a permutation example could be AB, and down here we can see BA. We can have AC, we have CA, we can have BC, and we can have CB as a permutation. As a combination, it can only be AB, AC, and AB. Okay, so combination order is ignored, and permutation order matters. Let's look at another example here. This is pretty simple, pretty straightforward. We'll import the math library and use math.com for short for combination, and math.perm short for permutation. So let's say we have a batting order. There's 10 players on the team, and we can choose the lineup as any three. With combinations, we can have 120. With permutations, we can have up to 720. Remember, permutations is always greater than the combinations with the same n and the same r. If we're talking about pizza choices and we have 3 toppings and 8 different options for toppings, right? Think of 8 different meat and vegetable combinations or permutations. If we have 8 possible and we choose 3, and let's say the pizza shop just says, hey, there's a limit of 3, that's just how we do it here. But you can pick any 8 that you can pick 3 of 8. That's what we're doing, 3 of 8. And we have 8, but we're not going to give you all 8. You can only pick 3. If the combination matters, you can only have 56. If the combination does not matter, you can have 336. Okay. Control Enter, and you probably figured this out anyway, but just to show you that you can add as many letters and numbers as you want over here. D, E, F, D, E, F, and you can see the list right here is kind of short, right? We only have up to 6. We start with 0, end with 5. If we have 6 letters instead of 3, the list gets a lot longer, right? Instead of 6, now we have up to 30, right? We start with 0 and go up to 29. So I'll just go back to ABC. That's a little bit simpler. I think it illustrates the point pretty nice. So again, combinations order doesn't matter, permutations order does not matter, and the permutations are always greater than combinations for the same n and the same r. Let me reset this, Control Enter. Okay, we just saw this example here. So this is batter lineup on a baseball team, picking 3 potential starters out of 10 total people. And if we're looking at combinations for items on a pizza, toppings on pizza, we have 8 different toppings. You can pick up to 3 with combinations. you'll have 56. With permutations, you'll have 336. And here's the math. This is how it works out down here. So ABC, if you have 3 different items here, if you're looking at permutations, 8 comma 3, you'd have 8 factorial, and then 8 minus 3 factorial. This results in 8 times 7 times 6. We have 336. That matches that down here. And if we're looking at combinations, 8 comma 3, we have 8 factorial divided by 3 factorial times 5 factorial, end up with 56. So we have 56 combinations. That's how we get 56 over here, and 336 permutations. That's the way we get 336. So pretty straightforward, and you can come up with all kinds of use cases for this, right? So in the real world, you would see all kinds of applications. So for a permutation, you could look at a pin code, right? The 4-digit number, the order matters. 1, 2, 3, 4 is not the same as 4, 3, 2, 1, right? So if you could use 1, 2, 3, 4 or 4, 3, 2, 1, that would be a combination, right? But obviously, if your pin is 1, 2, 3, 4, and you try to put in 4, 3, 2, 1, that's not going to work, right? This is a permutation type of problem. A bike lock is really a permutation. If you put in 10, 20, 30, and that order works, 30, 20, 10 is the same combination of numbers, but that's not going to work on a lock. It's not going to open your bike lock, right? It's really a permutation lock. You need 10, 20, 30 if that's the permutation, right? If you put in 30, 10, 30, 20, 10, or 30, 10, 20, that's the same combination of numbers, but it's not going to open the lock. So seeding charts, lineups for batters on a baseball team, I just showed you, that would be a permutation type of problem. Selecting from a group could be a combination, right? Pick any 5 volunteers from 12 to perform a task. The combination, that would be like a combination type of problem, right? A lottery number is a combination of numbers. If you pick 6 numbers out of 49, there's no particular order, right? If these numbers come up and you win the lottery, then that's the same as any order, right? So what else? Card hands, right, would be a combination. Example of a combination. Desk arrangements would be a permutation. You can arrange items on your desk any one of a number of different ways, right? There's lots of different variations there. If you're dealt cards in the hand of cards, then there's much fewer combinations, right? What else? Menu bundles, product kits is an example of a combination problem. Task scheduling is an example of a permutation problem. What else? License plates and tracking IDs is a permutation problem. ABCD, or no, wait, what is this? AB12CD is totally different from this set of letters and numbers, but in a combination type of problem, these would be the same letters and numbers, right? They're just arranged differently. But for a permutation, combination of letters and numbers on your license plate, this is completely different from this, right? If this was a combination, then these two would be basically the same thing. One other example, and I'll wrap it up in network routing, is more of a permutation type of problem, right? And you can have a bunch of different cities in different orders, or getting charged different distances, and maybe taxes in different jurisdictions, different time, traveling salesperson type of problem, things like this, right? That's a permutation type of problem. So that's it, guys. That's my take on combinations and permutations. Pretty simple, pretty straightforward. They just wanted to break it down for you and deliver that message. Hopefully that makes sense, and hopefully you learned a couple of things, right? Okay, that's what these videos are all about. It's all for education and sharing knowledge and that kind of thing, right? So that's it. I'm going to wrap it up here. I promised a short one, and I'm going to make good on that promise. I will download this code and share this with you guys, and I'll post the code when I post the video. All right, you can click the download button and have all of this HTML in a nice, clean, crisp HTML file, and you are good to go. You can copy and paste that into your Jupyter notebook and run it, and you'll get exactly what I'm seeing here, okay? So that's it. I'm going to wrap it up. Thanks for your time, and I'll see you guys in the next video. Take care for now. Bye.